Hi friends, we are going into class 3 of module 5 and in this class we are going to discuss a problem related to distribution of load within units of a plant neglecting the losses. So let's directly go into the problem. There are two generators of 100 megawatt each with incremental characteristics as shown here. The minimum load on each unit is 10 megawatt and the total load to be supplied is 150 megawatt. Determine the economic operating schedule. So here we have to prepare an economic schedule for the minimum fuel as a minimum fuel cost and the load to be met is 150 megawatt and there is a constraint that each unit should at least have a load of 10 megawatt. So this is the problem. Now we can find out how to make a solution for this one. So this can be done by the iterative process which was explained in the last class. So I'll be just showing you that flow chart. This was the flow chart and this is how you have to solve the problem. We have to start by reading all the values as of Fnn, that is the slope, then the intercept, PD and the small value that is a converging value. Okay, then we have to assume a suitable value for lambda and delta lambda. Okay, then we have to set for first bus we have to select and find what is the generation for this first bus and we have to check whether it is inside the limits. If it is violating the limit, we have to provide the value same as the violated limit and similarly we have to continue. So let's start with the solution. So step 1, we have to assume the lambda value. So the lambda value is normally selected such that it should be greater than the all the intercepts of the given generators. So here you can see in the problem this is the incremental characteristics and the intercept for this one is 2 and the intercept for this one is 1.5. So we have to select the value of lambda such that it is greater than 2 and 1.5. Okay, so let us assume here that the lambda value is 2.8. Okay, and now we have to go for the second step in which we have to find what is the generation of each unit. So we can find the generation by using the equation lambda minus Fn divided by Fnn. Okay, so lambda is 2.8 minus F1. What is F1? F1 is the intercept of the first curve. F1 is the intercept of the first curve. F2 is the intercept of the second curve. Fnn is the slope of the curve. So F11, this one will be F11 and this will be F22. Okay, so this is small letter F2, this one is small letter F1, intercepts. Okay, so using this we can substitute and find what is the generation of the first unit and the second unit. Now we have to add both units to check whether it is meeting the load demand or not. The load demand is 150 megawatt. So add these two, P1 plus P2, we will be obtaining as 153.2 megawatt, which means that now the generation is, this is the total generation, it is greater than the load and what we have to do now? It is not needed, we don't need to generate more than the load. So we have to reduce the total generation. For this we are going to make a variation for the lambda. We are going to make a slight variation. It is to be reduced. Why? Because we have to reduce the total generation. If it is to be increased, you have to increase the lambda of the system. So let's move on to the next iteration where we are going to change the value of lambda a little bit less than the previous value. Okay, so here you can see in the second step, second iteration, we are going to take lambda as 2.7 and we are going to repeat the same steps as done in the first iteration. That means we are going to find the value of P1 and P2 such that the new lambda value we have to select as 2.7. Okay, and you will be getting the answers as 58.4 and 80 and the total generation we are getting as 138.4 megawatt. So it is clear from this one it is not meeting the load. So what we have to do? We have to make a increase for lambda, then only we can meet the generation can meet the load. So it is less than the load demand. So again lambda has to be a little bit increased from 2.7. Okay, so we are increasing from 2.7. Let it be 2.75 and now we have to repeat the steps 1 and 2 again. That means we are again finding the generation value P1 and P2 by taking the value of lambda as 2.75. Okay, while doing the calculations you will be obtaining like this and the total generation you are getting as 145.9 megawatt. Again, this one is less than 150 megawatt. So what we have to do? We have to again uh, increase the lambda value. It is not still meeting the demand. So again, it is being changed, or we are increasing the lambda value to 2.78 for the next iteration. For 2.78, again we are doing the repeating the steps of steps 1 and 2. Okay, and we are getting the value for P1 and P2 as 65 and 85.4, and total generation is now 150.4. It is now approximately equal to the required load demand. 150 is the required load demand. There is a small error still, that is 0.4. So it is seen that the generators are converging for lambda value when we are selecting it in between 2.77 and 2.78. Okay, just go through what was the result during 2.75. It was 145.9, and if we are taking lambda as 2.78, you will be getting as 150.4. So your answer is in between this one. That means the lambda between 2.77 and 2.78. So somewhere in between this value you will be obtaining for lambda, you will be obtaining the correct value, that is 150 megawatt. So this the value selecting this 2.77 and or in between 2.77 and 2.88 will give the correct operating schedule. So this is how you have to solve this problem. Thank you everyone for listening. Study well and prepare.